So if I was to solve this one, first let's do it by logs. I would fish hook it, and so what would my base be down here? So log base 5 of 125 equals x. I would put log base 5 of 125 in the calculator, and it would give me 3. Alright, so we've done it that way already. That's kind of the way you should be familiar with it. Doing it by common bases. The idea behind this is to change the two bases that you have so that they share a common base. So I have 5 and I have 125. I can rewrite 125 as 5 to the power of what? 3. Because 5 times 5 times 5 is 125. So whenever you're doing common bases, you want to find the common base so that you can essentially cross them out. And then all you do is you make an equation with your exponents. Now, if one of your exponents is just x, then it'll be solved for. The next one will be a little bit different. Some of those are going to be a little more obvious than others, because on that one we only had to change 125. On number 2, we will have to change both 8 and 32 so that they share a common base. Okay, or written with their common base. Which, does anybody know what that common base would be for 8 and 32? Not 4, because 2. Okay. 2 to the power of what is 8? 3. And I'm just writing the 8 and the 32 right now. I'll get to the x plus 2 here in a minute. 2 to the power of what is 32? So 2 times 2 is 4, times 2 is, times 2 is, times 2 is, okay. So 2 to the power of 5. All I've done is I've just rewritten 8 and 32 so that they share a common base. But over here, I still have this x plus 2. So what that's going to turn into is a power to a power, which it's been a little bit since we've talked about that, but all you're going to do is multiply that. So again, we found the common base so that we can cross it out and just make an equation with my exponent and solve. So I would distribute my 3 first. Subtract 1. Divide by 3. If I was to do that using logs, what would my base be? Log base 8 of equals, okay. And so to solve for x, what would I need to do? Subtract 2. So am I going to have log base 30? Or am I going to have log base 8, 32 minus 2? How do I need to write that? The bottom one. Okay, you cannot, that 32 is part of that log. You can't combine it with the negative 2. And so that would equal x. And if you put that in your calculator, it would give you negative 1/3. So the majority of these down here, really all of them, we are going to do just log. We're not going to do common base. Just wanted to show you that method. I think there's one problem on the homework where you'll need to do that. Okay. So let's go to these. We're just solving. The majority of these, probably about 95% of these problems that you're going to see where you're asked to solve, you're going to have to fish hook. Okay, but sometimes you'll have to do stuff before you fish hook, sometimes you'll have to do stuff after. Okay, so for example, let's go to, well, we'll go through this. So what you want to do is you want to identify, you got to isolate your log, which is the log, where it says log, the base, and the analog. Alright, on number 3, there's nothing in front that I would need to divide by. There's nothing after it that I would need to add or subtract to the other side. So the very first thing I would do on this one is I would just fish hook it. So I've got 3 to the power of negative 2 equals x. And so x equals 1/9. Going over to 4, what is my base on that? 10. Yep. E. Okay, if it's natural log, it's E. If it's log without a base written down there, then it's 10. So there's nothing in front of the log. There's nothing after the log because that +1 is in parentheses. So I'm just going to fish hook. So I've got E to the power of 1 equals x plus 1. Then I would just subtract 1. How do I put E in the calculator? Second divide. So if I do second divide minus 1, that tells me that x equals what? Well, it should be 1.78. 1.72 what? 1.7182. Okay, so 1.72. All right, we're gonna do 6 together because this one encompasses a lot. So this one, it's in exponential, but my x is up in the exponent. So to do that, that means I've got to put it into log form. That's how I solve for x when it's up there, is to get into log. So I need to isolate the base and the exponent. We kind of talked about that in the last unit. So I need to get that red box by itself. So what would I do first? Subtract 1 first. So I'd have 1/3 times 6 to the power of negative 4x equals 5. And then, Edwin, what would I do? Then I would multiply by 3. Now what I had up there in the red box that's the only thing that's over there now. So now I can fish hook that. So I'm going to have log, what is my base? 6 of equals negative 4x. And then how would I solve for x right there? Divide by negative 4.
No, that
Alright, let's look at the back. So on the back, this problem right here does a pretty good job of comparing the two different ways we've talked about solving these, where we did the y1, y2, and you go down the table, or you can find the intersection on the graph, and then we'll look at it as with using logs, which is a lot of times is a lot quicker. But first, let's kind of walk through the scenario. It says someone buys a car for $24,900. It's expected to depreciate by a rate of 11%. So that means my B value is going to be 0.89. When the car's value falls below $10,000, Jack plans to trade it in and buy a newer model. Calculate how many years he should plan to drive this car. So the process is just the step-by-step process we would do to figure out the value of the car depending on the year. So on this first one, you would have the initial value times the B value to the power of 0. So it's brand new, which anything to the power of 0 is what? 1. 24,900 times 1 is 24,900. Then for the next line, we would take that, multiply it by 0.89 at 1 year. And whenever you do that, what that comes out to, someone throw that in there, I believe it's 22,161. For that next one, there's really two different ways you can do this process. So you can use that exponential formula that we've done in the past. So that means the process for 2 years would be 24,900 times 0.89 to the power of 2. Or what you can do if you're going through this is you can take the previous year's value and multiply it by 0.89. Both those are doing the exact same thing. The second one will really only work in this situation where you're doing it year by year. You're kind of going down the line. If I was just to ask you after 2 years what would it be worth, then I would do the first way. And so whenever you do that, you get that it's $19,723.29. So the next one, you would take that same formula. Instead of 2 years, you would put 3. Or you could do 19,723.29 times 0.89. And on this one, you would get $17,553.73. Then on this last one, I'm just going to write the exponential way to do this. After 4 years, you would put 4 in there. And that would mean the car's value is $15,622.82. We found all that using this formula right here. Which is what we will write down here below. It's asking the formula. So that is what we would use. So getting into the actual questions, the next question says write the inequality that describes when the value of the car is less than 10,000. So again, the equation we just wrote, that represents the value of the car. We want to know when that value of the car is less than 10,000. So we can do this one of two ways. Actually, there's three ways you could really do it. The first way we talked about is we would put in y1, we would put 24,900 times 0.89 to the power of x. In y2, we would put 10,000. And then you would go and you would look at the table. The only bad thing about the table is whenever you do it that way, you don't really get a very accurate answer. Okay? Because you would get that it is between 7 and 8 years. You could go look at the graph and find the intersection. So you would have 24,000. 0.89, so that's a decay. You would have 10,000 coming straight across, and you could find the intersection. The problem with that one is you'd have to adjust your window a lot so that you could see that intersection. So using a logarithm to figure out when the car is worth less than 10,000, you can take the inequality that we had before, and this is the way that I would recommend that you do it. And I'm going to solve for x. So what would I need to do first on this problem? Very similar to problems we saw in the front, it's just now the numbers are a little bigger, but the process is the same. Divide by. Okay. I need to get the exponent and its base by itself. So I'm going to divide 10,000 by 24,900. And now I can fishhook this. So I've got log. What is my base? What's the base of the exponent? If this is my exponent, what is the base? 0.89. Just fishhooking this. Okay, so log base 0.89 of, and I would just keep that as a fraction. So you've got 10,000 divided by 2,400, sorry, 24,900 equals x. I want everybody to put that in the calculator and see what you get. Do this and you figure out you should have gotten 7.83. Right, and on a lot of these word problems that involve inequalities, I would just use common sense. So if the value of the car is decreasing, as the car gets older, it's going to decrease. So whenever the value of the car, which is what x represents, is greater than 7.83, that's when the value of the car is going to be less than 10,000. So let's look at the next one. I'm going to zoom in a little bit here. So looking at 12. So it says, suppose $4,000 principal is invested in 6% that is continuously compounded. So what kind of formula are we going to use? A-PERT. It yields $5,333. So how long would it be in there for it to get to that amount. So I'm going to have my initial times e to the power of the rate, which 6% is a decimal, is what? 0.06. I'm finding the time that it would take to get to that value. So I identify the base that has the variable exponent. To get that red box by itself, what do I need to do first? Not subtract. Divide by 4,000. So I've got e to the power of 0.06x equals 5,333 divided by 4,000. Now, if I fish hook this and it has e, what does that mean? What kind of log am I going to have? Natural log, ln. So I have ln of that fraction equals 0.06x. And then what would I need to do to get that x by itself? Divide by 0.06. Again, everybody put that in your calculator because that's a little different than even the previous one. The whole thing is a fraction. So the very first thing I would put in there is alpha y equals enter. And then build it from the numerator down. On this, you should have gotten 4.79. Now, on this problem, it has a second question where it says, when will the original deposit be doubled? And so if the initial is 4,000, 4,000 times 2 would be what? 8,000. So we're figuring out how long it would take to get to 8,000. On this, guys, do not start off on step 1 and have 8,000 in there for 5,333. Alright, you did all the steps are going to be the same. So take what you put in the calculator, and instead of having 5,333, change that to 8,000. And if you know how to copy and paste in your calculator, then that's really easy. And put that in your calculator. I got a lot of people who would start all the way at the beginning just because I asked you that kind of question on this problem. And whenever you put that in, make sure that you get 11.55. So going down to 14. Okay, so looking at this, it says scientists found 4 bacteria in the water at Lake Louisville. They figured that it doubles every 12 minutes. How long will it take for the original 4 to become 2,000 is what that should be. So we're going to use, it's very similar to that half-life, but instead it's 2 instead of 1/2. So the initial value is 4. I'm going to multiply that by 2. I'm looking for the time. It takes 12 hours to double, 12 minutes to double. And I want to know how long it will take to get to 2,000. So everybody see how I got all that. I'm kind of going through this somewhat quick. Okay. Before I can fish hook this, what do I need to do? Divide by what? I need to divide by 4. Because it is just the 2 to the power of x over 12 that I need to get by itself. So I'm going to have 2 to the power of x over 12 equals 500. I would fish hook that, so I've got log base 2 of 500 equals x over 12 And then how would I get x by itself over there? Multiply by 12. So put that right there in your calculator. And Dugan, whenever you figure out what that equals, let us know. Okay. So it would take a little over an hour and a half for it to go from 4 to 2,000.